So I'm going to read the problem real quick, then I'm going to go back and break it down. Okay. So the product of a number, or product of 7 and a number increased by 3 is equal to twice the number subtracted from 39. We want to find that number. So as I start to break that problem down again, so the product, so I think, okay, what does product mean? Okay. Oh, product means multiply. So I'm going to do multiply. Well, what am I multiplying? I need to be multiplying things together, right? The product of 7, okay, I can multiply 7 by, some number. What do they mean by some number? Why are they saying that? Why aren't they telling me what to multiply by? Because we don't know what to multiply by, right? That's what this is all about. What are the things we don't know? And the things that we don't know in problems are variables. So we get to decide what to call this number. We have to call it some letter, since it's not a number that we know yet. So it can be X, it can be A, it can be P, it can be Q. I'm just going to call it N since it says number. Okay, if you want to use a different letter, go for it. So the product of 7 and some number, I'm calling that N, is increased by, well, what's increased mean? Okay. Oh, I should be adding. Well, what am I adding? I'm adding 3. Okay, I know I'd add 3. And it says, is equal to, there's really important. Equals, all right? I need an equals. This is supposed to be an equation. I better have an equal sign. Yeah. What's the next thing I see? Twice. What's twice mean? Twice means 2 times something. Doesn't mean add 2, it means multiply it by 2. So I need to multiply something by 2. What am I multiplying by 2? The number. What's this the number business? Oh yeah, we talked about that earlier. The number was, for me, it was N. Okay? And then it says subtracted from 39. We gotta be careful with subtraction. Subtraction is tricky when we talk. So if I asked you guys to write out, not tell me what it's equal to, but write out, how would we write out 7 less than 15? All right, I want to know what's 7 less than 15. The question was, something is 7 less than 15. How do we write that out? I don't want to know what the answer is. I want to know how to write it out. Yeah, right, June, it's 15 minus 7. So when we talk and when we math, they don't quite match up. Okay? And so there's an issue with that. I don't know if it's the English fault or if it's the math's fault, but they don't match. Right? And so when I say subtracted from 39, it's not minus 39, it's 39 minus. So I got to pay attention to that. Okay? And then, of course, our job is to figure out what the number is equal to. And I got to take all these things I was just thinking about and put it together into an equation. So the first thing it said was product of 7 and a number. So I said that was going to be 7 times n, which of course is just 7n. Increased by 3, which we said was going to be plus 3. Is equal to, so we need an equal sign. Twice the number, so 2 times that number, which was n again. And then subtracted from 39. Oh, forgot I wasn't paying attention to myself. I was supposed to say 39 minus 2n. That 39 has to go in front, right? With subtraction, division, order matters. I can't take, 7 minus 5 is not the same thing as 5 minus 7. So it's really important that when we write subtraction and division problems that we write them in the right order. And again, unfortunately, the math and the English don't always match up for us there. All right, is there anything on the setup that you guys have questions about? That's really the important part. Solving is easy. Anything you want me to go back over on the setup? This would be the part where you guys would say yes or no, and we can move on. Got one, all good. Anybody else? Okay. So, Kaylin, what should I do next? If I want to finish, if I want to solve this,
you would add 2n to 7n and subtract 3 by 39.
Subtract 3 from 39?
Yeah.
Okay. So yeah, canceling the 2 n's on the right, canceling the 3 on the left. Give us what, 5n equals 36. Something feels off.
No, you need to add. You need to make that
I
9.
need to, there we go. That doesn't yet. All right. Thank you, Caleb. Zoe, what's next?
Did you say me?
I said Zoe, but
Oh, all right.
okay. How about you, Jarrett? What to do next?
I think we divide, right?
Okay. Divide by what?
9 into 36.
Okay. So, of course, that'd be 4.
Yep.
And you can check that real quick. Just the product of 7 and that number. So 7 times 4 is 28. Increased by 3. So 28 plus 3 is 31. So I can remember that number because that's equal to. So all this was equal to 31. Twice the number. So 2 times 4 is 8. Subtracted from 39. So 39 minus 8 is 31. So this was equal to 31. This was equal to 31. So 4 works when we plug it in. And they both equal 31. So we can see that we did it right. Okay. I want you guys to look at number 2 and come up with some ideas about how we're going to write this equation or equation.
Real quick, where'd you get the?
Sure can. Mm-hmm.
Where'd you get the?
I'm ready, Brian. What's up?
7 less than 15 from?
Right there.
What'd you?
I was just making a point that when it says subtracted from 39, we have to make sure we write that as 39 minus, not minus 39. When we say 7 less than 15, what that means is 15 minus 7. The way we talk and the way the math works are backwards, right? We said subtracted from 39. We'd often write the 39 at the end because that's where it is in the sentence, but we actually have to put it at the front. So just pointing out that it's the same way here, that we understand what this means. This should be 8. The only way to get 8 is to do 15 minus 7. I can't do 7 minus 15. So just that the way we talk and the way we have to write the math are backwards. So we just got to pay attention to that. So I'd like you guys to look at number 2 and send me your ideas in the private chat so you don't influence anybody else.
Go back.
So that you can, we can talk about how you're supposed to write this equation or these equations. Okay. So look at number 2. Send me your ideas. I'm going to give you a couple minutes to think about what the equation should look like. So we can try to set that up. Again, send that to me in the private chat. And there's pretty much no chance you guys are going to get this right. So I just want, what we're really after here is that you're trying to see what you can make of it. Okay, so I want to see your ideas so we can talk about like the things that are good about it and the things that are bad, so you can start manipulating, what you're thinking. Because I've been doing this for a long time. I got a lot of practice of this. So you're taking a shot at it to see what see what's worse, see what doesn't, what you need to fix about your thinking, what you don't need to fix about your thinking. So see what you can come up with. Send it to me in the chat, and we'll talk about it. Got 2 ideas in. Oh, 3 ideas. Let's get a couple more ideas in, guys. No. Lost Sophia. Yeah, that's what they're saying, Audrey. Overall, it's going to end up being 29. Okay. All right. I just got more. So let's see. You guys are actually doing something. It seems like some of you guys are noticing something that nobody else has noticed all day. So here's one idea. If you'd actually stop typing in there, because now it's going to keep bouncing my chat, so I can't find them. X equals 9. Okay, so what I'm saying, like, and one of you guys specifically asked me in the chat that nobody else has talked about all day is this. So that's cool. You guys are seeing that. So it talks about one number, and then it says another number. So what that tells us is there are actually 2 different numbers here that we're talking about, and it really quite explicitly says that right down here. Find both numbers. So are you reading that and seeing that there are actually 2 things we're supposed to be finding here? And like I said, nobody else today has picked that up. So seeing that somebody's here, you got an N and an X, and there's an X and a Y, an A and a B, like those are really good things that I'm seeing, like that, picking up that that difference, right? That there's 2 separate things we're looking for here. So, did you find that or not, right? Did you see that or not? If not, just how do you incorporate that? Okay, I got to be a little more careful about my thinking now. Okay. So something, you know, so we got some number, right? X, A, B, whatever you want to call it, right? I don't know if I just called it X, that'll be my X. And you called it whatever you wanted to call it, that doesn't matter. So the next thing I see though is this, 9 more. What's 9 more mean? Well, that means plus 9, right? Or 9 plus. So where am I seeing that, right? Well, here I've got a 9 times. Ooh, that's not good. All right, I can't do 9 times for 9 more. Well, here we got a plus 9. Okay, here's a plus 9, here's a plus 9. Here's a 9 that's being added. All right, good. So a lot of people caught that. Twice the number. Okay, so what's twice mean, right? So that means 2 times, right? So, but it's 2 times a different number, right? But, you know, do we see 2 times? All right, 2 times, 2 times, 2 times, 2 times. It looks like all we got a bunch of 2 times, right? So that went well for most of those people. And then we have that other number. So what I'm not seeing on any of these is this right here. A lot of you guys skipped right over this word right here. And lo and behold, it's the most important word in the sentence. What does is mean in math? What does is mean in math? It means equals. Yeah, right, Kyla. Is means equals. So if I read this, x is 9 plus 2 times some other number. Again, whatever I want to call it. In this case, I'll call it y. So x equals 9 plus 2 times y. So there's an equation. I haven't even dealt with this yet. Yeah. If the sum of the numbers is 129, so what's that all about? What does sum mean? Right? Sum means add the numbers, right? I'm supposed to be adding, in this case, x and y. I need to add x and y. Well, there's is again. There's my equals, right? X plus y equals 129. So I don't know if you guys caught it when I was saying it. Well, I'm guessing you didn't, since you didn't do this, but I was saying write the equation or the equations. So there are actually 2 equations in this problem. I didn't tell you that when you started it. I wasn't expecting you guys to notice it. Yeah. But what parts are you noticing, right? What parts are standing out to you? Oftentimes when you're doing stuff like this, each sentence will represent its own equation. Because an equation is a mathematical sentence. And so to read this whole sentence as one equation, it's kind of seeing that. And then this whole sentence here would be the other equation. Okay? Now solving this is a whole other pig. Okay? And you guys have solved problems like this before in Algebra 1. And we've kind of done some of the solving stuff when we were doing something earlier, but we've never solved anything directly like this. That's not the point of this. The point of this is, can you read it and turn it into an equation or equations? That's the part I want to focus on right now. Is there something here you guys want to talk about in the setup? Because if you can't set the problem or problems up correctly, then there's no way to solve them correctly. So is there something here you guys want to talk about before we move on how to solve it? Okay, Audrey. All right, Kyle, thank you. So you guys, again, you've learned about solving systems equations before. You would have learned 3 methods for solving them back in Algebra 1. Graphing, elimination method, and substitution method. This would be the substitution method. And if you think about it, we've been substituting things in this class when we were doing our function composition. When we were plugging in one function into another function, we're kind of going to do that here. So what's wrong here with both of these equations, if I look at this equation, there's 2 things I don't know. I can't solve for that because there's 2 things I don't know. There's 2 things here I don't know. So I can't solve this. But I have 2 equations with 2 variables. Now I can solve it. And the substitution method tells us that since I know what x is this, I can take that and put it in here, which is something we did when we were doing the function composition. I can take that and I can substitute it into there. So I can take that 9 plus 2y plus y equals 129. And now I have one equation with one variable in it. All I know now is y. And that's a normal equation for us. Now I can solve this. Okay. So I can add those together. So 9 plus 3y. And I wouldn't stress about this too much because this is not what your homework's going to be like. But again, the setup is the really important part that you need to be focusing on. Okay. How did we set the problem up? Not that you're going to have to do any substitution methods, stuff like that. And then I'll subtract 9. 3y equals 120. Divide by 3. So y would be 40. But our job was to find both numbers. And have we found both numbers? Of course not. So what's x equal to? Now that we know what y is, how do we figure out what x is?
Add your
40.
9. 49.
Say that again, Aiden.
2 times 40.
So 9 plus 2 times 40. What's 2 times 40?
89.
80. So then plus 9 to 89. Okay, or the other way. What number plus 40 is 129, right? Well, what number plus 40 is 129? So 89, right? So we can see that it works for both. And you go back to the beginning too. One number, that was our x, right? I said x was 89. 89 equals 9 more than twice y. Well, y was 40. 2 times 40 is 80. 80 plus 9 is 89. 89 equals 89. The sum of the numbers is 129. 40 plus 89 is 129. So we can see that these numbers fit the criteria of the problem. Okay. So we know that's right. Okay. Again, kind of that idea that one sentence is one equation, and then another sentence would be a different equation. It doesn't always work like that, but it's a pretty good rule of thumb. Okay. Anything on 2 you guys want to talk about? June's good. That was good. Okay. Okay. I'll do 3 with you and we'll be done. Okay. This is definitely a problem you guys would have done in geometry. All right. So not that long ago. Just going to read over it real fast, then we'll go back and break it down. Okay. The length of a rectangle is 1 more than 4 times the width. There's a sentence. Read that right. The perimeter of the rectangle is 62 meters. Find the dimensions of the rectangle. Okay. So just one thing to think about, right? What's one sentence going to tell me? And what's the other sentence going to tell me? Notice I'm not highlighting the last part because the last part's the question. The last part's the directions. The purple part and the red part are the criteria, like what we need. As soon as I see this word right here, I want to draw a picture. Right? I want to draw a picture of this thing. It's going to help me. Not necessary, but could be helpful, right? We got a little bit of vocab. What's perimeter mean?
Area around something.
So close. Oh, you said a bad word there, Jarrett.
Not the area, but like the units around.
Yeah, the units are the distance or the length around. Yeah. Okay. Yeah, perimeter is those sides added up, right? Sum of the sides. We talk about a rectangle. It has a long side and has a wide side, right? Length and a width. And so we take the length plus the width plus the length plus the width, right? And that's how we can find perimeter. or there is a formula for it. It's 2L plus 2W, right? If we just combine those like terms up there, there's 2L's, there's 2W's. So there's the perimeter formula, right? So we had to generate that or remember that. But they also tell us what the perimeter is equal to, right? Perimeter is 62. So I can take that and I can put that in. I don't need this P. I know that the perimeter is 62, right? I don't need another variable, right? I know what P is, so I'm going to put that in. I don't know what L is. I don't know what W is, right? That's my job, to find W and L. Okay. So there's the second sentence. That's how we've made sense of it. Now what about that first sentence? The length of the rectangle. What's that those two little symbols right there? Right? Why is that so important, right? Is, right? Equals, man, find that is. Hey, there's another one, right? The perimeter is, 62 is, right? The perimeter, right? So the length is, L is, one more, 1 plus 4 times the width, 4 times the width. 1 plus 4W, or 4W plus 1. Doesn't matter which way you write it, because addition doesn't have an order, right? We can do addition any way we want. Okay? You decide which way you like it. I'm just going to do it the way it said it. Okay? So now I have my two equations. So I could do the same method that we just did on the last one. But again, that's not the point of this problem. The point is, do you guys understand how I did this? When you guys had to go back and remember this, I mean, or you're sitting there, you know, but like, is this one well enough for you to understand why I put the 62 in there? Okay. And the setup is the big thing here, guys. If you can't set up the problem right, then we're screwed from there. So again, the solving is not the big deal here. But just like last time, because we know what L is, okay, we can take that and put it in there. So what that would say would be 62 equals 2 times 1 plus 4W. So notice how the L went away, right? It's not supposed to stick around, just like we talked about with the function composition. Plus 2W. All right, why is that good to do that? Because now the only thing I don't know is W. I can solve an equation for one variable. I can't solve an equation for two variables. I can't solve an equation for two variables. I can solve one equation for one variable. Got some distribution to do. Again, this part should be easy. 2 times 1 plus 2 times 4 plus 2W. Combine like terms. So 62, so that's what, 10 W's? Check the time here. Subtract 2. Kind of paint myself into a corner here. Divide by 10. So it looks like W equals 6, and then we're talking about meters, so 6 meters. So then what's L? So if it's 6 meters wide, how long is it? Okay, Audrey. Sorry, I moved kind of fast there.
It's 25.
It's what?
5.
You kind of cut out 25, yeah. So 4 times 6 is 24. Yeah, plus 1 is 25, right? So 25 meters. Okay. Or you could have put the W back in here. 2 times 6 is 12. So then you take 12 away from here. That gives you 50. And then 50 divided by 2 would be 25 also. So it doesn't matter which equation you plug it back into. You get the same answer. Yeah, this one's the easier of the two, I would imagine. Yeah, so don't forget to add your 1 here, Audrey. But again, you guys, I don't need you guys to worry about solving systems equations. You won't be doing that right now. It's more about, can you set up the equations and solve a nice little linear equation like we did on the first one. Okay, where you're just writing one equation to solve. That's really where I want you guys right now. But the rest was just practicing writing equations. Anything spooking you out here? The assignment tonight should be really easy. It's just 5 problems. It's this. You guys have this picture. I didn't highlight them though, but this is the picture you guys have on the Google Class. Those are the 5 problems you need to do. First 2 will be just like yesterday. They're already set up for you. Last 3 you need to set up. I was offering to my other classes that if you want to write those 3 problems down and then like send them to me in the text or something like that, then I can check them before you solve them. If you're worried about, wasting your time solving the wrong equation, which is a valid worry. So if you're not sure that you set up 13 correctly, you can text me what you wrote, and then you can solve it once you know it's right. But it should be a pretty easy assignment.